In this recording, we're going to learn a new way to measure angles besides degrees, called radians. Now, it turns out this is actually a review from geometry, but I'm guessing since it's been a while, you may have forgotten or remember very little about it. So, I guess the important thing to recognize is, as it says here, just as we can measure distance in various units like inches, feet, miles, centimeters, we can also measure angles in multiple ways. We know about degrees, but there's also another way called radians, which is actually fairly useful, especially when we talk about graphs. Here's the way we define a radian. Okay? If you were to take the radius of a circle and whatever that length is, lay it out along the edge or circumference of a circle, that arc length would be considered 1 radian. And we're going to figure out how many of these radii would fit around a circle. In other words, how many radians make a full circle? So we're going to call our angle, our central angle, theta. Okay, radian angle, the central angle. And our arc length is going to be called S, as it says it here, and our radius is obviously R. So let's say we wanted to consider a full rotation around a point in a counterclockwise positive direction. So what is the arc length in terms of the radius of the circle? Basically what that means is make a formula for arc length using the radius. Well, we know that the formula for the circumference, the whole arc, is 2 pi r. So if we're going a full rotation, 2 pi r would be our arc length. Based on that definition, how many radians are there in one full rotation? Well, we're going to go to our definition of the angle, which is, okay, take the angle, and it's going to be a ratio, because it's not always one radius that you're looking at, so it's a ratio of however big the radius is, divide the arc length by that. So we're going to take our arc length from over here, 2 pi r, and divide it by r. So you can see the r's obviously divide out, and so our angle is equal to 2 pi radians. All right, that's a full rotation. So that's equivalent to 360 degrees. So that's the key important fact. 2 pi radians is equal to 360 degrees. They both mean the same rotation. Okay, so it's basically the number of radii that fit around the circle in a given rotation. So obviously there'll be 2 pi radians in one full rotation. So let's use that formula, that relationship between the arc length, the central angle, and the radius to answer a couple of questions here. Why don't you read part A, underlining the important stuff, and then play the recording when you're ready. Okay, so hopefully you paused and underlined stuff. The minute hand of the clock has a length of 5 inches, so that would be our R, the radius. The tip is traveling a distance of 13 inches, so that would be our S, the arc length. So 13 is equal to some angle times 5. And when we divide both sides by 5, we find out that theta, or the central angle, is 2.6 radians. Okay? Again, would you underline the important facts in part B and then play the recording when you're ready? Okay, so hopefully you did that. And you've got a central angle of 0.55 radians. That's our theta. The distance the tip travel is unknown. And the length of the pendulum is 8 feet. So S is unknown, 0.55 times 8, and when you do that calculation, you've got 4.4 feet of arc that the tip of that pendulum swings. And as it says at the top here, you're going to use radians in physics and in calculus. We're going to use it particularly when we talk about trig graphs. They're very useful for trig graphs. A lot easier actually than degrees. Right now it feels like a little bit of a foreign language. So be patient with yourself and be patient with this process as we try to get comfortable with measuring our angles in radians as well as degrees. So let's consider half a rotation. So that would be something like that. And we know that's 180 degrees. Okay. And we said a full rotation was 2 pi radians, so that would mean a half a rotation is pi radians. Well, this is the key unit conversion. Because these are equal, that means when I divide 180 divided by pi, 180 degrees divided by pi radians, that's got to equal 1, right? Because they're the same. You're dividing something by itself. So if I want to multiply 30 degrees by a unit rate in order to find it in radians, I'll multiply by something that is the same as 1. So pi radians, I'm just going to abbreviate it as RAD, divided by 180 degrees. You might say, well, what allows me to multiply by this fraction here? Well, we just said pi radians is the same as 180 degrees. So I'm dividing these out and I get a 1. I'm multiplying by a form of 1. And the advantage of that is the degree symbols divide out. And the 180 and the 30 have common factors. So I just get 1/6. So when I multiply this out, all that's left in the numerator is pi, and all that's left in the denominator is 6. So pi over 6 radians is the same as 30 degrees. In a few of these you're going to start to know, like 30 degrees is such a common special angle, you're going to start to know a few of these just by heart in radians. Okay, so let's do that same thing. I'd like you to pause and then play the recording when you've worked out parts 4A, B, and C. Okay, so hopefully you worked these out. I'm going to kind of go through these quickly and you can see the conversions. You might notice that we don't always write the unit on it when it is radians. Like you see no units here for this 5 pi over 6. Down below even, this 5.8, you don't see any units. It's understood that it's radians if it has no units. So it's really important that we do put our degree symbol if it's degrees. And again, I'm just including the units here of radians for clarification because we're new to this, but it can be written just as 5 pi over 4. And that's how we pronounce this. This one we would pronounce 2 pi over 3. This one we pronounce pi over 2. Okay, so let's reverse that process. Let's take a radian measure angle and express it in degrees. So we'll write it as 5 pi over 6. I'm going to multiply by the unit rate. This time I want it to be in degrees. I want the radians to divide out. Matter of fact, let me create a little space here so that I can write in the unit. I think this will help. So I'll call it 5 pi over 6 radians times, I'm going to multiply it by 180 degrees over pi radians. And I want the units to divide out. That way I'll know I have it right. Radians divide out, the pi's divide out. I'm looking for common factors, so 180 degrees and 6 leaves me 30 degrees in the numerator. So now I just multiply the 5 and the 30 degrees. They're the only factors left. 150 degrees. Okay, so could you please pause the recording and proceed with parts B and C at your own pace? Okay, so hopefully you got those. If not, please work them out. Okay, and finally, we can convert radian measure that is not in terms of pi. We just saw in the previous page that sometimes we get angles like 2.6 radians that don't have any pi in it. That just means it's not one of our special angles like multiples of 30, 60, or 45. So we can convert these similarly into degrees. We're just going to say, okay, I've got 5.8 radians. I'm going to multiply by the conversion factor, so that unit rate, which is 180 degrees over pi radians, because I want the radians to divide out because I want degrees to be in the answer. And there's nothing special here to simplify it, so I just go to my calculator and multiply 5.8 times 180, then I divide that by pi, and then I have my answer. Okay, so could you finish these out, please, by pausing and working out parts B and C on your own? Okay, so hopefully you took care of those. So 4.2, we're going to convert, and then we're going to convert the negative 2.5. We'll just work through these fast. Okay, now in this final example, I'm going to use this one as our quiz. So see if you can convert 2 radians into a degree measure. That will make it a little easier for you to consider what quadrant that will terminate in, and then try the quiz. Thanks for watching.